In this lecture, we're going to perform a Kruskal-Wallis test. The Kruskal-Wallis test is a version of the independent measures, or one-way ANOVA, that can be performed on ordinal or ranked data. Ordinal data is displayed in the table below. Here we have 3 groups and we have 6 scores for each group. Is there a difference between groups 1, 2, and 3 using an alpha level of 0.05? We're going to perform a Kruskal-Wallis test on this data set to see if there's a difference between the 3 groups. Our Kruskal-Wallis test has 7 steps. First, we're going to define what our null and alternative hypotheses are. Next, we're going to state our alpha. Then we're going to calculate our degrees of freedom. Then we state our decision rule. Then we actually calculate the test statistic. And then finally, we state our results and our conclusion. So let's start with step 1, defining the null and alternative hypotheses. For a Kruskal-Wallis test, our null hypothesis, H0, is that there is no difference between the treatments that we're comparing. Our alternative hypothesis, H1, is that there is a difference between the treatments that we are comparing. Step 2 is to state the alpha level. That's easy because I already said use an alpha level of 0.05. Next, we're going to calculate our degrees of freedom. Degrees of freedom are equal to k minus 1, where k is the number of groups you have. So, in this case, our degrees of freedom is equal to 3 minus 1, or 2. Next, based on that information, we state our decision rule. Here we go to our chi-square table, which is what we use for a Kruskal-Wallis test. We have an alpha level of 0.05 and 2 degrees of freedom. Using that information, we can find our critical value. Here, our critical value is 5.99147. So, if the chi-square value that we calculate is greater than 5.99, we can reject the null hypothesis and say that there is a difference somewhere between the 3 groups. If chi-square is not greater than 5.99, then we will not reject the null hypothesis. Now let's actually calculate our test statistic. Here we have our information. I just moved it over to the left so we can work with it. And what we want to do for a Kruskal-Wallis test is organize our scores by rank. So basically we want to organize them from smallest to largest. Here we have 3 groups with 6 scores in each group, so we have 18 scores. We're going to rank those 18 scores so we can calculate the chi-square statistic for our Kruskal-Wallis test. Here we've just taken the original scores and ranked them. For example, our smallest score is 2, so that's rank 1, while our largest score is 36, so that's rank 18. So now I've changed the table to reflect that. We're no longer working with the original data, we're working with our ranks, because remember, our original data is ordinal. So now we have our table with our ranks. So now we can calculate our test statistic. Our test statistic, we're going to call it H, but just basically think of it as a chi-square value. And here we have our equation for calculating that. It's this kind of complicated 12 divided by n times n plus 1 times all of the sums squared divided by n minus 3 times n plus 1. That sounds kind of confusing, but I'll show you right now how we actually get those numbers. So first, our t is our sums. So for example, the sum of group 1 is 39, the sum of group 2 is 65, the sum of group 3 is 67, and our n is just our sample sizes. We have 6 scores in each of our groups in each of our samples, so all of our n's are 6. So now that we have that, we can just plug those into the equation to solve for h. For each t square, t1, 39, t2, 65, t3 is 67. Our big N reflects our total sample size, so while each small n is 6, our total sample is 18. It's just 6 plus 6 plus 6. And we just plug all of those values into the equation to find our H value of 2.854. So now we can move on to our results. Remember, our decision rule was if our chi-square value was greater than 5.99, we were going to reject the null hypothesis. In this case, our value is 2.854. Because it's not greater than 5.99, we do not reject the null hypothesis. Now we state our conclusion. Basically what that means is that there is no significant difference among the three groups that we compared in this Kruskal-Wallis test.